Advanced Math Lesson 38, Fundamental Counting Principle and Permutations, Designated Roots, and Overall Average Rate. Fundamental counting principle and permutations are pretty simple. A permutation is quite simply this. If we start off with the letters A, B, and C, all of these are permutations of A, B, and C. Pretty much reorderings, rearrangings, different possibilities of writing A, B, and C. Now, permutation implies that you cannot repeat any numbers. Now you notice none of these options say AAA, BBB, or CCC. Excuse me. So permutations do not allow repetition. Now, there's a really simple rule to figure out permutations. And the easy rule is that if I have three letters I want to put in order, right, A, B, and C, in the first box, if I do not allow repetition of those three letters, A, B, and C, I have how many options? I have three options, right? So the first box has three options. Now, if I'm not allowing repetition, how many options are there for the second box? I've already used one, so that takes away one of my three, so I now have two options left. Now, the last box, after I've already used two options, how many options will I have left? I'll only have one option left. So in order to figure out the total number of possible permutations, I take the possibilities to fill each slot, I put them in order, and then I multiply them. So the first box has three possibilities, times two possibilities, times the final possibility, which gives me 6 total possibilities to arrange the letters A, B, and C. And that's the way permutations work. You take, again, permutations do not allow repetition. So you take the possible number of objects that can be used, and you multiply them by the next scenario, the next scenario. Now let's say I wanted to arrange three letters in a row, and I was able to use all 26 letters of the alphabet. I wanted to find out all the permutations I could create only using three letters, but I'm allowed to use all 26 letters of the alphabet with no repetition. Well, the first box, I have 26 options. In the second box, I've used one, so now I have 25 options. In the third box, I now only have 24 options. So the answer to that would be 25, 25 times, I'm off today, 26 times 25 times 24. So take those three, multiply them. I have 15,600 ways I can put three letters of the alphabet in order without repetition. Now, these are permutations. Now, what if repetition is allowed? Well, we're going to follow the same rule. So if repetition is allowed and I'm only using the letters A, B, and C, in the first box, I have three options, right? Now, in the second box, I still have three options because I can repeat whatever letter I put here. And then in the third box, I still have three options because I can repeat that number. I can put AAA, BBB, CCC, or I can go AAB, AAC, BBC, BBA. I can repeat. So it's the same rule. You put however many options you have in each available slot, and then you multiply. So 3 times 3 times 3 would give me 27 different ways I can write the letters A, B, and C if I allow repetition. If I was using the whole alphabet, it would then be 26 times 26 times 26, or 26 cubed. So I just type in 26, and then up 3. 17,576 ways. So that's permutations, and that's the fundamental counting principle. The fundamental counting principle is essentially what I just described using these boxes. They're going to give you some logic word problems using those, using that rule, and it's really easy to solve. So I'm not going to spend much more time on that. The next thing we're going to talk about is designated roots, or this actually falls on the concept of zeros with graphing. I don't think we're talking about that yet. So we're just going to talk about designated roots. Right over, right here. Designated roots are kind of like possibilities for x. So when we're talking about quadratic equations and we're talking about trinomials with an x squared term like this one, if we were to factor it or use quadratic equation or complete the square to solve it, we usually get a plus or minus answer, or we have multiple roots. Those and the answer would be referred to as a root. So that's what they're talking about with these problems. Now, they're going to tell you to write a quadratic equation with a lead coefficient of, I'm out of focus. With a lead coefficient of 1 whose roots are -3, 5, or -3/5 and 1/2. So what they're saying here is these roots are kind of like what we would call zeros on a graph of the equation, which we haven't learned yet. Until we get to the zeros, this is a little difficult to actually explain logically. So I'm just going to tell you, the designated roots are what we would have if we could factor the quadratic perfectly. So if they tell you the roots of a quadratic are -3/5 and 1/2, what they're saying is that quadratic can be factored into x plus 3/5, yes, plus opposite signs, and x minus 1/2. So that's what they mean by roots. If you were to take that quadratic and factor it, it would factor into these two polynomials. And they want you to write the quadratic formula, or the x2, x1, x none term. So all you have to do when they tell you write the quadratic that has these two roots is you set it up into polynomial form using opposite signs. Yes, the signs have to be opposite. And then you FOIL to get the answer. So x times x is going to give me x squared. 3/5 times 1/2 is going to give me, -1/2 is going to give me a trail term of -3/10. Right, so I've got my first times my first, my last times my last, my middle times my middle, or my inside, 3/5 x, and then I'm going to get -1/2 x. So now I have to add these two together. That can be written as 6/10 x minus 5/10 x. Once I give them common denominators, 6 minus 5 is 1. So I've got -1/10 x. And this is the answer right here. So when they give you roots, take the roots, put them into polynomials, opposite signs, FOIL them, add like terms. That quadratic is what they're looking for. Once we get into graphing quadratics, we'll see how these roots become more valuable. You'll understand what I mean when I say zeros on the graph. It'll make a lot more sense. Last thing we're going to learn today, overall average rate. This probably sounds harder than it actually is. It's very similar to just finding the average. I know whenever we hear the words rate, distance, or time, we all have nightmares of distance, rate, time problems, or boat in the river problems now, with all kinds of crazy substitution and stuff like that. These problems are much easier. And it's summed up by this equation right here. The overall average rate is equal to the overall distance divided by the overall time. So all you're going to have to do is add up all the distances, add up all the time, divide distance by time. You get your average rate. First example. Frank and probably only one example, so I can finally make a video that's less than 10 minutes long in a week. Frank and Judy drive for 100 miles at 50 miles per hour. So first thing I'm going to add up. 100 miles, 50 miles an hour. Oh, wait, no, I'm sorry. I need to add up their time, sorry. So if they travel 100 miles at 50 miles an hour, how long were they traveling for that 100 miles? That's easy, 2 hours, right? 50 miles per hour times 2 hours, 100 miles. So the first distance is going to be 100, first time is going to be 2 hours. Next, they drive 180 miles at 60 miles an hour. So if I divide 180 by 60, I get 3. So next one, 180 miles for 3 hours. And then they want to know what is Frank and Judy's overall average rate over the whole trip. So all I have to do is just add 100 to 180, which is going to equal 280. And then 2 plus 3 is 5. So I've got 280 miles over 5 hours. All I do is divide or simplify. 5 goes into 28 5 times. 3, 5, 6. So 56 miles in 1 hour. That is their average rate. It is that simple. The only math we really have to do is use the rate and the distance to figure out the time. Why does this thing keep going in and out of focus? So we take the rate and the distance to get the time. If you need to see it again, we'll do one more. So this time, Frank and Judy drive 100 miles at 50 miles an hour. So again, that's 100 miles. What is going on? There we go. So 100 miles at 50 miles an hour means 2 hours. So distance, time. Again, they're going 180 miles again for 60 miles an hour. So that's 180 miles at a time of 3 hours, because 60 miles an hour into 180, 3 hours. Okay, and then this one, they want to know how fast must they drive for the last 120 miles to have an overall average rate of 60 miles an hour for the entire trip. Now this one is a little bit trickier. So the last leg we know is going to be 120 miles, right? The last time, we do not know. Last time I'm going to put X, or you could put T. Now what they do tell us is the average rate should be 60 miles an hour. We know that if we knew this and we worked it out, the answer would equal 60. So all we have to do now is just solve for X. So we'll add like terms. 100 plus 180 is 280. So that's 280 plus 120 gives me 400. So I've got 400 over 2 plus 3, which is 5, plus X. So what I actually have here is 400 over 5 plus X equals 60. I can multiply each side by 5 plus X. That will cancel. From here, I'll go ahead and divide by 60. So I've got 400 divided by 60 equals 5 plus X. That looks like 5 times X, huh? Okay, 5 plus X. Cancel some zeros. 6 goes into 40. Does that work evenly? No. That'll be 20 over 3. From here, I'm just going to subtract 5 from each side. And then X is going to equal 20 over 3 minus 5. So 20 over 3 minus 15 over 3, after we give the common denominator, is going to equal 5 over 3. So X is going to be 5 over 3 hours, or 5/3 of an hour, or we could say 1 2/3 hours. And there we go. Now, oh wait, I'm sorry, that's not the last thing. They want to know, let's see here. They want to know how fast they need to drive for that 120 miles. So for 120 miles, traveling at a time of 5/3 hours, so the distance of 120 miles is going to equal the rate times the time of 5/3 hours. To find the rate, all I have to do is multiply by the reciprocal, 3 over 5. 5 will go into 120 24 times. 3 times 24 is 72. So the rate is 72 miles an hour. Sorry, I found the time, they wanted the rate. Those are, again, they're not too hard. You just gotta remember overall distance divided by overall time equals overall average rate. If you're missing one, just put an X, solve the equation, and you can figure out the rate at the end. If you have any questions, let me know on Moodle. And I guess this video didn't go under 10 minutes. Sad day. I'll see you in class.